Okay, this is the second video of a new topic for IB this year, and it's definitely causing me to work hard, so you're going to have to practice. There's just no other solution to that. So this is the example from the textbook, and I'm going to do the best I can to explain it and talk you through it. So they're asking you to consider the binomial expansion of this 1 over the square root of 2 plus x. And they want the first 4 terms. So the first thing we want to do is we want to recognize that 1 over root 2 plus x, that's equal to, well, 2 plus x raised to the negative 1/2 power. Okay, so now we know that our n value is a rational number, but it's not an integer, so it's a little harder to work with. So the way that the book teaches us to do it is they want this to become a 1 right here. So this would be equal to, I could factor out a 2. And all of that's raised to the negative 1/2. Okay, so now at this point, if that's the case, this is multiplied by this, well then each one of those can be raised to the negative 1/2. So this is 2 to the negative 1/2 times 1 plus x over 2 to the negative 1/2. So the book's example works with, they turn a, if you're thinking of this as being a plus b to the n, a is now 1, is how the book works through our problems. I don't know that it has to be, but let's make sure we understand what they're showing us, and then we'll go from there. Okay, so this is 1 over root 2, if we want to write it that way. And then this part right here can be written as the sum as r goes from 0 to infinity of, well, then the combination is this n choose r times then this x over 2 to the r power. Okay, so if you think about it, when I'm expanding everything, I've got a combination, and then, so let's back up and make sure we know where all that comes from. If I'm just doing a plus b to the n, what I've got here is I've got a particular row of Pascal's triangle, so it's the first term would be like n choose 0 times a to the n times b to the 0. And then the next term would be n choose 1 times a to the n minus 1 times b to the 1. Okay, and then we've got the combination n choose 2 times a to the n minus 2 times b to the 2. And this keeps going until we get to n choose n times a to the 0, b to the n. That would be the last term, there's a plus sign, a last term in our expansion. Well, so they don't want to write out a random number of things. So what they've said here is this is the sum as r goes from 0 to n of, well, it's n choose r, and then a to the, okay, hang on just a second. I forget. I should go look at the book. But this becomes b to the r, and this would become a to the r minus n. I said that totally wrong. A to the n minus r, and then b to the r. So does that work? Let's see. If I plug in my first term as 0, I have n choose 0. N minus 0 is n. Yes, that's good. And then b is raised to the 0. Good. And if I plug in 1, n choose 1, a to the n minus 1, b to the 1. Yes. Okay. So they have rewritten, they've expanded this out. We can see this is the sigma notation. So over here, we're doing the same sort of thing. The only difference is our a value is just 1 because we factored that out, and so we don't need to consider that. So here was our combination. We're going from 0 to infinity because this thing, we can have infinitely many terms. And then here's our b value to that power. Okay, so then they told us to write down the first 4 terms. So what we need to do is we need to plug in 0, plug in 1, plug in 2, plug in 3. Okay, so this would be equal to, my elbow keeps squeaking on the desk. Okay, so this would be equal to the very first term. When I plug in negative 1/2 choose 1, this is, I lied, choose 0. Anything choose 0 is equal to 1. And then anything raised to the 0 power is equal to 1. So the very first term is just going to be 1. So there's the first term. The second term, now we have, we're using that formula that we saw before, which was n times n minus 1, all the way down till we get to n minus r plus 1, all over r factorial. Okay, so that means on this next one, I plug in 1, that means this is going to go to n plus 0. So all I need is n, which is negative 1/2, divided by 1 factorial, and then this gets multiplied. So I've taken care of, so this one, when r is equal to 1, all I get is this right here. Okay, and then this part right here becomes x over 2 to the first power. And so this now is, here's term 1, here's term 2. Here comes term 3. And so that's going to be when r is equal to 2. So when r is equal to 2, we have a negative 1/2 times a negative 1/2 minus 1, all divided by 2 factorial times x over 2 squared. The third term, we're going to have a negative 1/2, negative 1/2 minus 1, negative 1/2, I didn't save my space, so sorry. Where's my edge of my paper? And then this gets divided by 3 factorial, and then I don't have room, I'm so sorry. This is going to need an x over 2 cubed. Okay, and that's the first, and I need to close my parentheses, but okay, whatever. That becomes my first 4 terms of this expansion. So cleaning this up, I have 1 over root 2 times 1 plus, this will become a negative 1/2 times x over 2 becomes a negative x over 4. Is that how they wrote it in the book? No, they said 1/4 x. Okay, well, I'll fix it in a second. This becomes, I have a plus a negative 1/2 times a negative 3/2, and this is divided by 1/2, and this is over x squared, this x squared over 4. So kind of cleaning all of that up. Okay, hang on. Now this becomes a negative times negative is a positive. I have a 3 in the numerator, and then I have a 2 times 2 times 2, that's 8 times 4 is 32. Okay, and then that was term 1, 2, 3. Here comes term 4. This is a negative 1/2 times a negative 3/2 times a negative 5/2 times, I still didn't save any space, times 1 over 6, because 3 factorial is 6, and that's in the denominator. And then I have, right over here, I have an x cubed over 8. Oh my, okay. So close parentheses. So this gives me a negative times a negative times a negative is going to be a negative. 3 can cancel here, making that a 2. So I have a negative 5 in the numerator. 2 times 2 times 2 times 2 times 8. Well, 2 times 2 times 2 is, that's 8 times 8 is 64 times 2 is 128. And this has an x cubed that you couldn't see because I ran out of space. I'm so sorry. And this, ladies and gentlemen, is, they put plus ... Okay, so when they said write out the first 4 terms, this is what we end up getting. Okay, and I checked my work as I was going, so that's correct. The next thing that they asked was, in part B, they said state the interval of convergence. Okay, and for the complete expansion, those are their directions. Okay, and so what we find is that that's going to be negative absolute value of a over b is going to be less than x, which is going to be less than the absolute value of a over b. Okay, so when we look back, when we look back up here, a was 2 and b was 1. So it's negative 2 is less than x, which is less than 2. And that's part B to that problem. And then they want us to figure out what would happen if we're evaluating, hang on, I need a new piece of paper. Oh, okay. They want us to say, well, what happens when I am, in part C, they say use the expansion to estimate. So sorry, you can't see what I'm doing. Use that expansion to estimate that. Well, if you notice, this would be equal to 1 over the square root of 2 plus 0.1. Okay, so what we have here is in this expansion right through here, what we want to do is we want to plug in x is equal to 0.1. Okay, because these are the first 4 terms. And so I can come through here and now say this is 1 over root 2 times 1 minus 1/4 times 0.1. Well, 0.1 is 1/10. I don't know if that's going to be easier or harder. I'm still learning these things, so you guys, you gotta practice also. Okay, so this would be an estimate of that. I don't know that off the top of my head, but I could find a calculator. And did I do that the way they did it? I sure did. Okay, so when I come back to my calculator, I have 1 over root 2 times, oh, my bad, times 1 minus, well, 0.25 times 0.1 plus 3 over 32 times 0.01 minus 5 over, do you see how I'm mixing all my, oh, my bad, times 0.001. And they get this, 0.690064, okay, and there's our estimate. Now, if you look at this, 1 over the square root of 2.1, okay, come on, calculator. I'm going to change that to a decimal, and notice, look how close we are. So we get off after 1, 2, 3, 4, 5. By our 6th decimal place, we're different than what the calculator is able to give us from that. Okay, practice, 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 practice. Good luck.